man. Okay, I think I'm live now. So, wow, YouTube has made this really hard. But I guess there's a lot more features, so I just need to learn them. Okay, so I don't think no one's in the call yet, so I didn't even finish this whole chapter. It turned out to be a lot more to it than I was expecting. I had worked through another exercise on regular expressions and thought this one would be a piece of cake, and then he decided to very exhaustively kind of just encyclopedic make sure we knew everything about regular expressions from this. So I'm actually just going to start reading around where I left off, which was after the date portion. Talking about word and string boundaries. So, unfortunately, find_date will also happily extract the nonsensical date 0013000 from the string 100,130,000. The match may happen anywhere in the string, so in this case, it'll just start at the second character and end at the second to last character. If we want to enforce that the match must span the whole string, we can add the marker caret and $. The caret matches the start of the input string, while the $sign matches the end. So /caret \d plus $sign matches a string consisting entirely of one or more digits. Caret bang matches any string that starts with an exclamation mark, and x caret does not match any string. There cannot be an x before the start of the string. Right, because the caret in this position does the opposite of the pattern match, which he says early on here. Or talks about, just in case we wanted to do the opposite of a test. Where's that? Yeah. to invert a set of characters. To express that you want to match any character except the ones in the set, you can write character after the opening bracket. Yeah, so in this case it's in a bracket, but I think that's when you're using that with brackets. I think someone may have just joined. Nope. Oh, keep reading. Does not match any string. If on the other hand we wanted to make sure that the date starts and ends on a word boundary, we can use the marker \v. The word boundary can be the start or the end of a string, or at any point in the string that has a word character, as in \w on one side and a non-word character on the other. Note that a boundary marker doesn't represent any actual character, it just enforces that the regular expression matches only when a certain condition holds at the place where it appears in the pattern. Choice patterns. Say we want to know whether a piece of text contains not only a number, but a number followed by one of the words pig, cow, or chicken, or any of their plural forms. We could write 3 regular expressions and test them in turn, but there's a nicer way. The pipe character denotes a choice between the pattern to its left and the pattern to its right. So I can say this: var animal count equals b, so that's the beginning or boundary, d for any digit, and then plus space. So, and we're also testing for a space here, and then a selection of pig, cow, or chicken using the pipe, and then s optional in case it's plural or not, and then we have another boundary, and that's the end. So if we test 15 pigs, it's going to be true, meaning that it's going to match the entire string in this case. And then if we have pig chickens, it's not going to match because it's not going to match both of the parts of the string there, and pig chickens is not one of the options. However, if we made this pig chicken, yeah, it would say true, and then pigs isn't going to match because it's not pig, so we could add pig, and then they both match. Parentheses can be used to limit the part of the pattern that the pipe operator applies to, and you can put multiple such operators next to each other to express a choice between more than 2 patterns. The mechanics of matching. Regular expressions can be thought of as flow diagrams. This is the diagram for the livestock expression in the previous example, with a boundary, then a digit, and then a space, and then the group pig, cow, chicken, the s optional, and another boundary. Our expression matches a string if we can find a path from the left side of the diagram to the right side. We can keep a current position in the string, and every time we move through a box, we verify that the part of the string after our current position matches that box. So if we try to match the 3 pigs with our regular expression, our progress through the flowchart would look like this. At position 4, there is a word boundary, so we can move past the first box. Still, at position 4, we find a digit, so we can also move past the second box. At position 5, one path looks back to before the second digit, to the second digit box, while the other moves forward to the box that holds a single space character. There is a space here, not a digit, so we must take the second path. We are now at position 6, the start of pigs, and at the 3-way branch of the diagram. We don't see cow or chicken here, but we do see pig, so we take that branch. At position 9, after the 3-way branch, one path skips the S box and goes straight to the final word boundary, while the other path matches an S. There is an S character here, not a word boundary, so we go through the S box. We're at position 10, the end of the string, and we can match only a word boundary. The end of the string counts as a word boundary, so we go through the last box and have successfully matched this string. Conceptually, a regular expression engine looks for a match in a string as follows. It starts at the start of the string and tries a match there. In this case, there is a word boundary, so it get past the first box. But there is no digit, so it fell the second box. Then it moves on to the second character on the string and tries to begin a new match there, and so on, until it finds a match or reaches the end of the string and decides that there's really no match. Backtracking. Okay, so new topic. The regular expression boundary 01, so it's going to try to match exactly. I'm just going to read this and then we'll try to analyze it afterwards because this one looks pretty complicated. The regular expression matches either a binary number followed by a B, a regular decimal number with no suffix character, or a hexadecimal character, that is base 16, with the letters A to F standing for the digits 10 to 15, followed by an H. This is the corresponding diagram. Boundary. Then we have this this whole thing. So it's either one of O or 1 going in a circle until it hits the boundary. And then the boundary, if it gets to a digit, just proceeds. And if one of A through F, and it also has an H, it will go to the next boundary. Standing for the digits 10 to 15. Alright, I'm just going to go on. When matching this expression, it will often happen that the top binary branch is entered even though the input does not actually contain a binary number. When matching the string 103, for example, it becomes clear only at the 3 that we are in the wrong branch. The string does match the expression, just not the branch that we are currently in. So the matcher backtracks. When entering a branch, it remembers its current position, in this case at the start of the string, just past the first boundary box in the diagram, so that it can go back and try another branch if the current one does not work out. For the string 103, after encountering the 3 character, it will start trying to branch for decimal numbers. This one matches, so a match is reported after all. The matcher stops as soon as it finds a full match. This means that if multiple branches could potentially match a string, only the first one, ordered by where the branches appear in the regular expression, is used. Backtracking also happens for repetition operators like plus and star. If you match caret dot star x against abcxe, the dot star part will first try to consume the whole string. Remember here, the dot will mean multiple things. If it's within a bracket, let's see, if it's here, it's going to match any character. Dot star part first run, try to consume the whole string, right? But what was the thing about? Already forgotten. When you put a plus sign after something in a regular expression, it indicates that the element may be repeated more than once. Thus, \d plus matches one or more digit characters. The star has a similar meaning, but also allows the pattern to match 0 times. That's right. Something with a star after it prevents a pattern from matching. It'll just something with a star after it never prevents a pattern from matching. It'll just match 0 instances if it can't find any suitable text to match. A question mark makes the pattern optional. In the following example, the U character is allowed to occur, but the pattern also matches when it is missing. So this is demonstrating like 2 different types of English spelling. And the part I was looking for was about specifically the dot, the differences between the dots when they occur. I might actually have a note here. Backslash. Nope. Alright. just going to be confused for a minute. It's good. It's good to be confused. Let's see if anyone's looking. Nope. It's good. Click. If you match caret dot star x against abc xe, the dot star part will first try to consume the whole string. The engine will then realize that it needs an x to match this pattern. Since there's no x past the end of the string, the star operator tries to match one character less. But the matcher doesn't find an x after abcx either, so it backtracks again, matching the star operator to just abc. Now, if we find an x where it needs it and reports a successful match from position 0 to 4, it is possible to... now it finds an x where it needs to blah blah blah. It is possible to write regular expressions that will do a lot of backtracking. This problem occurs when a pattern can match a piece of input in many different ways. For example, if we get confused while writing a binary number regular expression, we might accidentally write something like that, like this here. And this is just going to, remember, take O1 any number of times. A set of either O or 1 any number of times. And then it's going to treat that, because the plus here is on the outside, it's going to treat this entire group element as a repeatable match until it gets a B character. So if that tries to match some long series of zeros and ones with no trailing B character, the matcher will go through the inner loop until it runs out of digits. Well, then it noticed there is no B, so it backtracks one position, goes through the outer loop once, and gives up again, trying to backtrack out of the inner loop once more. It will continue to try every possible route through these two loops. This means the amount of work doubles with each additional character. For even just a few dozen characters, the resulting match will take practically forever. So we have this really major big O dilemma there. The replace method. Yeah, probably go back and look at this and then go back and look at this really long one and actually try to analyze it. You can kind of see what's going on. Any digit, any number of times, and then any digit followed by A or F, treating that as a sum until it gets to H, and then we have another boundary at the end. Yeah, it seems pretty complicated though. The replace method. String values have a replace method, which can be used to replace part of the string with another string. Pop out replace M, P, M. So the string here, it's going to look for the P character and then replace that with M. So we get mappa. So it looks like replace is only taking, and this is pretty common because replace is just a function here, so it's taking the single argument of the character P and then matching the first one that it finds. First argument can also be a regular expression rather than just a string, in which case the first match of the regular expression is replaced. When a G option for global is added to the regular expression, all matches on the string will be replaced, not just the first. So if we make this a regular expression and then do G, we get mama. And here's another example. Anytime we get the OU, we replace it with A. So Borobudur, we'll get Borobudur because the OU together, or I'm sorry, the first O that it finds will get replaced with A, so we get borrow Bador. But then here, when we use the G flag, anytime O or U is found, it's going to get replaced with the A, so we get bara batter. It would have been sensible if the choice between replacing one match or all matches was made through an additional argument to replace, or by providing a different method, replace all. But for some unfortunate reason, the choice relies on a property of the regular expression instead. The real power of using regular expressions seems to occur a lot. The real power of using regular expressions with replace comes from the fact that we can refer back to matched groups in the replacement string. For example, say we have a big string containing the names of people, one name per line, in the format last name, first name. If we want to swap these names or remove the comma to get a simple first name, last name format, we can use the following code. Console log Hopper, Grace, and then a new line character, McCarthy, comma John, new line, Richie, comma Dennis. Pretty popular names. And then we call a replace on this string, and we're replacing the any character here, any word, or I'm sorry, any I believe W is any non-alphanumeric character. So that's going to be all the special characters as well. So anything followed by a space, any number of times, and then a comma, and then a space, and then the same. We're going to replace with $2, $1, which I think are going to take, so this is like bash arguments almost. It's going to recursively look at whatever the first and second match is and swap them. That's really cool. Yeah, let's look what it says. The $1 and $2 is the replacement string, refer to the parenthesized groups in the pattern. $1 is replaced by the text that matched against the first group, and $2 by the second, and so on up to $9. The whole match can be referred to with $and. It's pretty cool. So I wonder what happens if we change this to and. So that's our first match. Grace. Oops. So we replace these. Yeah, Hopper. That's quite cool. It's also possible to pass a function rather than a string as the second argument to replace. For each replacement, the function will be called with the match groups as well as the whole match as arguments, and its return value will be inserted into the new string. Here's a simple example. var s, the CIA and the FBI, console.log, string.replace, passing it the regular expression boundary B with the groups FBI or CIA boundary global. And then the function which takes a string and calls string to uppercase. So the function is going to be called on every one of the elements that the regular expression matches. So since it's FBI or CIA, and I think internally it's actually doing some array manipulation, but the end result is going to be what's returned from the replace function, which is going to be the entire string with those two matches being returned from the callback function. So in effect we get the CIA and FBI, same sentence, but with CIA and FBI uppercase instead of lowercase. And here's a more interesting one. We have var stock equals 1 lemon, 2 cabbages, and 101 eggs. We have a function -1, which takes a match, an amount, and a unit. amount is equal to calling number on the amount minus 1. Then we ask if the amount is equal to 1. Only 1 left. Remove the s. That's just that's a explanatory comment. If amount is equal to 1, then set the unit to unit calling slice starting at the first character up to the length minus 1. So we want an array with all of the character matches from the unit argument. Else if the amount is 0, so yeah, we're thinking like 1 lemon, 2 cabbages, 101 eggs. The amount is no. We just set that to no. And then we return amount plus the space plus the unit. So we're then going to call replace using the regular expression of any digit of the space and then any character globally minus 1. So it's going to match 1 and it's going to return no because that that amount has already been subtracted 1 based on this declaration, which gets called the first time that the function is executed. So amount there, since it's 1, is going to be set to 0. And then 1 cabbage, same thing. Since we have 1 left over, it's going to call slice and yeah, and then return that minus 1. I'm sorry. It's going to call slice, which is going to take the unit here, and then yeah. Did I miss the part about the arguments? Right, so that's the same as the $1 and 2. So remember the same thing here. This was just simply a matter of reversing them. So wow, they kind of didn't specifically declare it. Okay. The 1 and 2 in the replacement string refer to the parenthesized groups in the pattern. So the parenthesized groups here, 1 is going to be the digit, and then 2 is going to be the word. Digit with a space, and then whatever the next delimiter is. 1 here being any number of non-alphanumeric strings. So it's going to actually go up to here and then stop because it gets to this new string, and then that's a match. Yeah, so if it's equal to 1, now remember here, that means there's only 1 left. So what we're doing here is removing the s from the end of this entire pattern, which is going to be matched. So we're going to slice. We're literally just taking this whole thing, which is going to match, and then just removing the last element from it, which is this s, and then setting that to unit. So then here what gets slogged is amount plus space plus the unit. And so unit yeah, it's just going to be cabbage because we're not actually doing it. We're not capturing the space. That's what I was confused about at first. This here, the space is just, we need that space to be there, I think. Yeah, because otherwise we get like 9-1 because it matches 10. So we need some way of delimiting that. Yeah, that makes sense. Okay. This takes a string, finds all occurrences of a number followed by an alphanumeric word, and returns a string wherein every such occurrence is decremented by 1. The \d plus group ends up as the amount argument to the function, and the w group gets bound to unit. The function converts amount to a number, which always works since it matched d for digit, and make some adjustments in case there's only 1 or 0 left. Okay, so now we're going to get into the greedy. And I've seen this argument before, so it's going to be interesting to see. Sorry. I'm going to turn the light on. It isn't hard to use replace to write a function that removes all comments from a piece of JavaScript code. Here's an attempt. I guess I don't need. I'll just leave one of these in case somebody starts talking. Still waiting on you guys. But get here. Sorry, I cut that out. Greed. It isn't hard to use replace to write a function that removes all comments from a piece of JavaScript code. Here's the first attempt. We have a function called strip comments, which takes code and it returns, which I assume has to be a string since they're calling replace. The escaped // any character, any number times star, so it'll match even 0 times, or escaped / escaped star the caret in the bracket in this case means not star and then escape star escape / any number of times and then replace it with empty string. So if we have here a string, which would be like a stringified expression, I guess, with the 2 here commented out, it should actually just remove the comment. So we could say, like, if we had like a code parser, and before we wanted to like minify code, one thing that we can do to make the file smaller is to remove all the comments. So that's exactly what this function does. It looks for either 2 / or / star *, which are the 2 ways of doing comments in JavaScript. Yeah, so just 3 examples. So we would expect this to be removed, and then everything after that to be removed, and then this and this to be removed. I would actually expect that. I wonder why that plus is also getting removed, because that plus should be there. Huh. Maybe he's going to talk about that. Or maybe I'm reading it wrong. Let's see. The part before the OR operator, so this pipe, simply matches 2 / characters followed by any number of non-new line characters. Okay. Is that one of our globals? Oh, the dot, any character except new line. I was looking for that earlier. The part for multi-line comments is more involved. So multi-line comments, that's our slash star. So this is just matching two forward slashes. So this is the beginning of the regular expression, and then the escaped forward slash, and the second escaped forward slash, and then anything, which I guess is anything except new line characters. Which, boom, is what that is. The dot, any character except for new line. The part for multi-line comments is more involved. We use the, bracket, caret, any character that is not in the empty set of characters. As a way to match any character. We cannot just use a dot here because block comments can continue on a new line. And dots do not match the new line character. Okay. So that's an even more. So anything character that is not an empty block of characters, which I guess could just be like a bunch of spaces. We cannot just use a dot here because block comments can continue on a new line and dots do not match the new line character. But the output of the previous example appears to have gone wrong. Why? Oh, that's right. Okay, so that's that plus. The caret star part of the expression, as I described in the section on backtracking, will first match as much as it can, so it's greedy. If that causes the next part of the pattern to fail, the matcher moves back one character and tries again from there. In the example, the matcher first tries to match the whole rest of the string and then moves back. In the example, I'll just read it one more time. In the example, the matcher first tries to match the whole rest of the string and then moves back from there. So it continues on and tries to match the rest of the string. If it doesn't, it goes back. It will find an occurrence of star slash after going back 4 characters and match that. This is not what we wanted. The intention was to match a single comment, not to go all the way to the end of the code and find the rest of the last block comment. Because of this behavior, we say the repetition operators plus star. Hello. Hey, Jay. What's up? Hey, that's fine. You're, I've just been reading to the camera for an hour. Yeah, right now. I expect maybe more people might show up, but man, it was taking me a long time to figure out how to set up the the whole YouTube streaming thing. This new setup, and I'm not sure. I'm not sure if I'm recording your voice right now. I was trying to do that, but oh, and you probably can't even. What do you see right now? Do you just see my face? Okay, let's see. So yeah, so I'm using this thing, this like streaming software that I got to use because Hangouts on Air doesn't exist anymore. So, and I was trying to use something. There was this thing called Soundflower. Maybe I have to use. I'm not even sure yet. I'm trying to record like the audio pass through for my audio channel, but I'm not sure if I've correctly done that yet. try this. So I got built-in microphone, Natty. Yeah, I think that's it. Oh, there we go. Yeah, it looks like it's working. Yeah. Okay, cool. So it's probably, I think this is my input, and then which it's also getting, and then but the second one I think should be yours. Try saying something. Yeah. Okay, cool. Well, I guess. Yeah. Hopefully it sounds okay. It might. Maybe I can make. I can probably just delete all the other channels except for the pass-through if it's getting both of them. Or like turn that all the way down. Yeah. Yeah, it seems like that's what, if I just have all the channels, which I think that's what this, it's really hacky, like Mac almost doesn't want to let you do this, it seems like. But yeah, hopefully, because I'm trying to stream the book, and then also have the Hangouts and my notes, and I think it's working. I can preview it here. Yeah. So it's streaming. It's not up to the point where I added those other channels yet. It's a little delayed. Yeah, how'd you like this chapter? Right. Yeah, I mean, I think that's a good word for it. I was hoping to spend it. I mean, honestly, this is not a super fun subject, and I was hoping to spend a little more time on it. But I worked through this other website called Regex1, and I worked like all the way through that, and I thought I was in decent shape. But then starting to read this chapter, I felt like I just knew nothing again. Yeah. That's yeah, I think that's the nature of the beast a little bit. Let me see if the audio is coming through. Sorry, I'm still. No, I don't think I'm getting your audio on the stream. Dang it! Oh, that sucks. Sure. Let me try turning up these other channels. Mm-hmm. Like the groups. Right, exactly. Yeah. Yeah. Because can you? Yeah, I think he only mentions Unicode like one. Unicode standard. Right. It will match. Oh, capital W? Is that what? Can you use that to do non-Latin? Yeah. What's the deal with the underscore? Oh, sure. Yeah. That's right. Yeah. Oh, got messages. Well, I'm just gonna have to work on this streaming thing. It's kind of a bummer. I guess maybe I can just unplug. Like, maybe this won't feedback if I just unplug my headphones. Are you?
Yeah.
Okay, so.
Okay, I'm hearing myself now.
Oh, you are? Oh, yeah, of course. Dang. That's the problem. I knew that wouldn't work. How can I have it? Well, really what I want to be able to do is just use the audio pass-through from Hangouts as one of my audio channels. But it seems to not give me that option. Scene, game capture, window capture, audio input capture. I think that's what. Maybe I have to use it as a. I don't get it. There's got to be a way to do this. I just don't know how to do it. Yeah, I like the that little function for removing comments. That was pretty cool. Pretty useful. We're getting up to the point. I mean, you can see where he's dropping hints that I think we're going to be writing our own language at some point. Awesome. Okay. So, I was just on this beat. I don't know. Well, it's just you right now, Jay. What would be the best use of your time? I was just reading. I was literally just reading the text here. Yeah. Yeah, we can do that. and maybe just call it a short one tonight. Okay. Oh yeah. Cool. Yeah. Yeah. Right. Yeah. Yeah, I haven't looked at that at all. Yeah, just like the first, let's see, what's the first lesson? Oh, yeah. Alright, so, oh yeah, Regex Golf, which, I wonder if there's a website for that. I know there's a Regex, or a Vim Golf. Wouldn't surprise me if there's a Regex Golf website. Mm-hmm. Mm-hmm. Have you seen Vim Golf? I think it's just vimgolf.com. It's yeah, it's that for Vim. So it's like the minimum number of keystrokes to do something. Because Vim programmers are obsessed with that. Yeah. Yeah. I think the first time I opened something in Vim, I was I think it ended up like I couldn't close it, so I ended up like turning off my computer. Just it's like almost threw it out. Oh, it looks like there's a book. Is this a real book? Yeah, Peter Norvig. Man, my computer's going so slow with the streaming. Why is iTunes open? Gosh. It would appear O'Reilly has a book. Oh. It's loading. Yeah. Cool. I'm closing all my windows that I can. It's going so slow. Alright. So it looks like we're trying to match. Yeah, it's just a set of them. Car and cat, pop and prop, ferret, fairy, and Ferrari, etc. Okay. So I'll switch back to screen sharing. Not that it matters. So I guess CA and then just R or T. Where is it? Okay. It didn't log anything. Is it supposed to log if it works? That makes sense. Okay, so we can check it in Regex 101. Have you ever used this? Looks like they updated it. Wow, they updated it a lot. So I think we can use. So this one would match. Okay, so it matches the CA in there, and then, whoops, yeah, matches that whole thing. And we can do it in JavaScript to make sure. Yep. So car and cats will pass with, but yours is definitely shorter with the brackets. Yeah. That's pop and prop. So that makes sense. It's weird that it's not logging anything. I wonder if I'm getting error. Even debugger. It's just going so slow. I might just turn off the stream since, no one else is in here. I'm just going to do that.